soils. And what happens, it's a quick clay, literally turns into a fluid mass, literally pours out of a container. So this goes from a solid, rigid mass into a liquid material. And obviously anything and everything above it is going to sink in, and we have one type of subsidence. Then it sinks into this pit. Limestone is CaCO3, calcium carbonate. We talked about this last time. You add a little bit of H2CO3, which is rain, and we dissolve the limestone. Cap rock is just a name given for any rock that happens to be on the surface. It could be sandstone, it could be marble, it could be anything. So it's anything on the surface. Water filters on through the cap rock, whatever it is, into a limestone base, hits the limestone and begins to dissolve the limestone. So we end up with a series of cavities below the surface. Well, obviously the cap rock can only support itself so long without anything underneath it. And eventually this stuff is going to basically collapse. And what we'll see happening in areas such as this, there's your cap rock, and you end up with a series of little depressions. These depressions are called sinks, and a group of depressions in a given area is referred to as karst topography. And if you go to Florida, you look at all those lakes, what you're looking at is a series of sinks. Parts of Texas, parts of Kentucky and Tennessee, all these little lakes are sinks because the limestone has dissolved from beneath the surface. All of these depressions form a subsidence. It's a slow process initially, but finally collapses. Cars have disappeared, houses have disappeared into these things. Blocks of highways simply disappear. Again, with modern technology, they can avoid these sinks. If you're traveling in areas such as Florida or Texas, and the road does something like this nice little straight highway all of a sudden does something like this, odds are that somewhere over in this area there's a sink that could collapse. So they steer clear of that, and eventually that is going to disappear. Beginning of the semester, we talked about the hydrologic cycle. Two components of the cycle I'd like to just mention this morning. I hope to get a little further than I did. You will recall that on the hydrologic cycle, we had precipitation, and then we had either water flowing across the surface of the earth. Water that flows across the surface is referred to as runoff, and it need not be moving. Water on the surface is runoff. Lake Superior is a form of runoff. Lake Wassa is runoff. The creek in your backyard is runoff. So any water on the Earth's surface is referred to as runoff, even though it may not appear to be moving. It is moving, it is leaving the Earth's surface gradually over time. So we have runoff, which is surface water, and then we have water that literally filters into the ground, and we call this subsurface water. The factors that determine how much goes where are such things as slope. The steeper the slope, the greater the runoff, obviously. Surface materials. The more bedrock we have, the more runoff. The more soils, the greater the infiltration. Plant life. The more plant life we have, the more humus we have. What's humus again? Partially decomposed organic matter. The more plant life we have, the more humus we have, the greater the infiltration rate, slower runoff. And lastly, the type of precipitation. And with this, we're looking at two factors. If the ground is frozen and snow melts, that snow will run off. When you hear these people say, oh, great, we've got a ton of snow. But if the ground is frozen, all of that stuff runs off. It doesn't sink in. Frozen ground is impermeable. So that's one of the things we're looking at. And the other thing is the intensity of the rain. A nice light drizzle, more infiltration, less runoff. Heavy downpours, runoff, and less infiltration. Okay, let's look at subsurface water. That's the sequence in which your authors take the topic. How many of you live away from an urban area?
Pull the sheet down.
How many of you live on a house out in the country? And your water source is your well. Okay, most rural homes, water source is a well, subsurface water. Some small communities use subsurface water. And when I say small communities, generally less than 40,000. Wausau probably uses the Wisconsin River. I know Marshfield uses subsurface water supplies. So some communities will use subsurface, but most will use surface waters of one type or another. So if we look at our subsurface water supply, let's start off with our box spruce trees. We'll add some walnut. In the first several feet of the Earth's surface, we have what we refer to as soil water. If you were in the lab portion of the class, this is what we were dealing with. This is the water that's available in top line. The field capacity is determined by the type of sediment. So you have soil water here. Soil water is hygroscopic water. You can't tap into it for your consumption. Plants can tap into it. So literally, it provides moisture for your plants. When this water is depleted, plants begin to wither. For your water supply, we have to go well below this. Typically, the next layer is referred to as a zone of aeration. And this is basically a dry zone. Water filters on through the zone of aeration. Then we get into the zone of saturation. And this is truly the groundwater that you're searching for. This is what provides water for rural areas and small communities. The top of the zone of saturation is referred to as a water table. Water table is a term that is somewhat misleading because it would imply a flat surface. But a water table, if this is a landscape, your water table mimics the landscape. So if you have hills and valleys, your water table will show that same